Hey, welcome back. I had to make 4 little adjustments to the control system to make it a little bit tighter. There's just a little bit of slack in there, and I don't know if this is something that you can use, but this is what I did. Wish I would have thought of this sooner, but I've got all this stuff put in here and I'm not taking it back out again, even though it's just clecoed, because I have to spring this one quite a bit. As you can see, I've got this just sitting here, and the bad news is that I had already cut those 4 holes in, not knowing that this was this way. I thought it was flat. And then I found this in my goodies upstairs. I guess I thought that was a part for the tail or something, but I don't know. Now I know. So I had to just rivet these covers in to block the hole that showed on each side. And I'm going to leave that to be my fix. I could make it pretty, or I could go and get another panel and have it shipped out here, but I'm not going to do that for just being stupid. So, but I did find out these holes work just fine for me, because I decided to take the bell cranks back out because I just took the shim that goes in the middle, the bushing, and I just put it in. I didn't really measure because it bottoms out on that bushing, and then the bearings on each side are what keep it from wobbling. And mine has quite a bit of wobble in it, chuck. So I decided to take that out, and I measured it, and I took a few thousandths off, and I put it all back together. And every time I did it, it got a little better. So I did that side, and it came out really good. So if you're not thinking about doing that, and you are going to put this all together before this goes in, and you want to check that, but the bell crank goes back and forth a little bit when it's tight on the bushing, then maybe you want to do this step. If you have a hard time taking cotter pins out, here's a little trick. You got to get one of these little hooks. I don't know if you can see it. A hook. And do like I just did with the screwdriver. Just open up the first one. The one that's bent in the back is hard to get back out straight again. And once you get that one bent down just a little, enough so that you can lift it up to get the hook in. Maybe I can give you a better shot of this. Once you get that front one bent down enough to get a hook in, then pull tight and turn it. And every time you turn it, that one in the back will get a little straighter, the one that's hard to get at. And just keep pulling. And every time you get into the tension spot, give it another turn, and that thing will keep sliding right into its place next to the other one. And next thing you know, it's out. The other thing is, if you put these little access holes in, you can do this kind of work when it's sitting on the table. I have no way to get up in the hellhole right now, so I wouldn't be able to do this unless I took this completely apart. So these are already coming in handy. If you don't know what this looks like, there's a flat surface there that's the controller and a bolt sticking through, and that's what all this stuff is going to be put on. It goes like this bearing, a sleeve on it on the bolt, the actual bell crank that's sitting down in the bottom goes on here. This sandwiches to it, and then this washer goes on the end of the bolt. So what this spacer does is sets the depth of how much these squeeze on the bell crank, which is going to be mobile. And mine was, you could grab it and really move it back and forth quite a bit. So the only alternative is to take this down. So let's see how much we're going to take off this thing. In inches, let's zero it out. Right now it's 0.394. I think we're going to take it down to 0.379. That, somewhere right in there is where it gets nice and snug, where you got minimal. You still got movement. It's still rotating on the grease really well, but it just doesn't have as much play. The way I'm doing this is simply, I don't have any real flat method to do it, except that I just stay even. I go back and forth like this, then I turn it, quarter turn, keep going like this, another quarter of a turn, and I just keep doing that until I get it down to that depth. This was exactly 10 millimeters. And now I've got it down to 9.54. I'm not going to go down to 9.5. It'll be too tight. I just had it completely installed. It worked good. I did take it back apart so I could show you the numbers, and I want to clean it and re-grease it and set it all back in. But what a difference it makes. It still turns just as free as could be, but it doesn't have that big chuck in it. Well, all the pieces are ready to put back in. Let's load it up with grease, and we're doing this a second time. Boy, I'm so happy with how that worked out. You can reach right in there. Now to get the bell crank back up and in its position. Help if I pull up on this rod. Okay, I grabbed a new nut in hopes that the threads and the lines are cut in, the grooves are cut in this castle nut. When it gets to torque setting, that the pin will be right in the middle. Well, this is something I probably should have addressed in the beginning, but I didn't think it would be that big a deal, but it kind of is. There's this wants to go, as you can see down in there, there's a gap. And this wants to go back and forth. And because it's a little angled, if you can see that, let's see if I can focus in. See, it's angled. So when it's up all the way, it's at its loosest point. And when it's down all the way, it's at its tightest point. And its tightest point still wobbles. So you're gonna be flying nice and level with it up and flaps up, cruising along, and any variance that pushes on the ailerons or flaperons will wanna move back and forth unless they're identical pressure at all times. So I imagine when you're turning, I guess it'll go one way, and then if you turn back, it will chuck back the other way and stay there from the pressure. But what I'm gonna do is I'm going to build a shim. I'm going to take these two bolts out and get two longer ones and new ones and put I got the same material, it's nylon, and I'm going to just make a shim because it doesn't have to be the bearing, it just has to go where this tab comes up, and I'm going to have it all one way, and then I'll even angle the shim is the plan, and we'll see how it comes out. And it should hit that shim when it's up all the way, and then at the lowest point hit the shim, so it'll have the same pressure on both sides. This is what I'm going to make it out of. It's an 1/8 inch. I will have to sand one side of it down so that it has that wedge appearance, but that's what I'm going to make it out of. I think I could just simply take a sharp object and poke through and get it centered, because it doesn't have to touch this. I just figured it would give it good support besides the two bolts. So as you can see, I poked a pencil through one of them, stuck the bolt in there to hold it, and stuck a pencil through the other one because you can tell exactly where it is, and it just reams the cardboard out until it fits. So I'm going to try drilling that and making a template out of it. That worked. Well, I've test run that quite a few times, and there's no tension on it. I put a dial marker on the side here, and it moved out 0.04 of a millimeter. So it is resting when I'm in flaps down position. It is resting against that shim just a little more than when it's up flying. But it's nice and snug. It's not going back and forth anymore. So really pleased with that. Well, I put a copper sleeve inside there because the A3, the hole that was drilled in this was way bigger. So I put a copper fitting in the center of that to take up the slop, and now it fits nice and snug. Well, all that I just told you was a lie. What I did is I took the sleeve back out. I told you that there was a steel sleeve welded into this, and cleaned it out, and it fits a perfect AN 516. I decided there was plenty of room on this to drill that out and just put that bolt in there and use the sleeve that they welded into the tube to keep it from collapsing when you tighten it. And I've got it quite snug, and I can put I got a castle nut on there, and that's what I'm going to end up with. It has a little resistance, but it also doesn't chuck anymore. So that makes me happy. But when I did this, I thought it was this, but it wasn't. It's that. I don't know if you can see it, but... So I'm going to take a piece of this, cut out a piece to put right in here, and match it up really nice and drill a hole through and bolt that in, but I'll have that drawn right over tight. Apparently something is just a little smaller than it should be. I'll try to get, I'll get the shot so you can see the bell crank and see this. At the same time, I'll move it over here so it's easier for me. That's just that play. Bell crank isn't moving at all. So I got to get that out of there. We don't want that. I don't think we want that. All right, onward. So I'm going to make a piece, drill a hole in a piece, and put it right in that gap right there and shove it over to the right. And that should hold it from doing that. Some pretty thick 1/4 inch nylon that I'm going to drill a hole in and make a piece to slide right in here, and so I can shove that over nice and tight and drill a hole through. And I think I have the room in the back. I'll take a quick movie of it so I can see if I've got room for that 3rd bolt through there without hurting anything. I think I do. Well, after looking in the back, because this opening right here, if I line my bolt up right directly with these, it'll go through this and the aluminum just perfect. So, and I'm going to go with a much smaller. I upsized these to 4s because in my previous video I showed you that I drilled those out for number 6 rivets, and then the 3s were sloppy in there, so I upsized these and bought new bolts with the right shank size, or grip size I mean. Anyway, so that's good. We're ready to rock and roll. I'm gonna start making a pattern now to fit that. Boy, that's tough stuff. I haven't done any measuring yet, but I just drilled the hole past halfway. I'll probably have to stop about exactly halfway. We'll see how it fits. Now I'll start making a pattern. Well, that was quite easy. I just eyeballed it. I just kept trimming down, but that fits in there just nice and tight. Hopefully I can shove it up. Yeah, in one bolt, and then it won't twist because it's got support of these 2 pieces. That fits really well. All right, I cut that piece out and I built a little wedge here so I could shove it in there super tight, and it took all this play out, and believe it or not, having it go underneath a little more on the bottom, it shoved it up, so we took some of the up and down play out also. So right now it's sitting, it's not, the trick is going to be get that hole drilled nice and snug, but yeah, it's not chucking anymore, just this is. So I'm going to come up with something for up here. But this is going good. I just got to drill a hole and I'll show you how it worked out and then cut off the excess. But I'll draw a little line down from the top bolt to the bottom bolt to figure out where to put it. All right, that's coming out really good, but I got a quick question for you. What keeps this whole rod from coming out forward like that while you're flying? Is it just the cable tension? Because that stops it from going back. It's got a bearing there that's greased. I'm going to pull that ahead and grease that and put that in, but The only thing I can see, I didn't see anything in the paperwork that retains this from going forward. It must be just the even cable tension. If you know of something I might be missing, please comment down below, because I can always put that in. Well, it ain't pretty, but it sure does work good. I had to push it over quite hard with this wedge, and when I drilled it and cut off the extra, it was hard to get that pushed over far enough to get that bolt in. So it's holding it really secure, and because that curve is a little bit further under than it is on top, you know, just the fortunate mistake that happens from making something out of your with your bare hands and not a CNC machine. It's underneath just a little bit further than it is on top. So what it does is it pushes it right over, but it also wedges it up. I was only planning on pushing it to the right there in the picture, left in the airplane. But yeah, there's no play there at all anymore. And it feels really free. I'll come up with something. If it works really good, I'll mention it in the video or in the next one or something. So we got number 1 done, number 2 done, we've got the bell crank done, and the far end done. And I think we'll call this done. Guys, thanks for coming along. I hope this does somebody some good. We'll see you in the next one.